All right, so we're recording on this computer. Let me go ahead and I'm just going to share my whole screen. So we're taking a look at Module 7, Part 2. So we're continuing with those sysadmin skills and those foundational knowledge of how Linux does the stuff that it does. And remember, what is the main purpose of an operating system? Yeah, we control access to resources, right? So we're going to look at a few other ways that Linux does that today. So these are the commands you should know already. I'm not going to go over them today. I'm not going to go over the variables. Well, actually, I will do one. What is this right here? Standard error, yes, right? So this is redirect standard out. The 2 is redirect standard error. The other one is to append, right? So that really deals with the output file. This changes the input stream from standard error, because standard error is totally separate from standard out in Linux, which makes sense. If I'm, maybe I want to redirect all my output, but I still want it to show me if there's an error, right? Unless I want to redirect that somewhere as well. So that's separate. All right, good. New commands we're going to be looking at this week: cron and at. We're going to look at real user ID, effective user ID, AAA, and we're going to look at PAM. So fire up the NetLabs you have. So you guys all watched the video on cron, right? So I'm not going to get too into it, but if you do vim/etc/cron tab, this is the general format of the main cron tab. Now, in almost every modern system, each user has their own cron tab, right? For very good reason. In ye olden days, they would just let everybody put whatever they wanted in here. And it became a nightmare. And everything that's run through this one, which is the system cron tab, runs as admin. That's dangerous, right? So you really only want things here that have to run as root. But they all have that same kind of format. What is the first column here? The minutes, and then hour, then day of month, day of the week, the user it's going to run as, and then the actual command. So this one is going to be on the 17th minute. What does this mean? Every hour, yes. So every hour, on every day of the month, on every month, on every day of the week. And it's going to run as root, and it's going to cd into root, and then run dash parts, and it's going to output a report. Okay. This one is going to run on the 25th minute of the hour 6. So it's 6:25 a.m. But again, it's going to be every day of the month, every month of the year, every day of the week. So that's the cron tab format. Make sense? Okay. I'm not going to get too into it. Nope. And then all of these other directories are going to be typically, like, I could put a script in cron daily and it'll automatically run it every day. I could put a script under cron hourly. So that's another way you could make things run. But the most correct way is to use cron tab. And then cron.d will often hold the scripts that you want it to run. You'll keep them in there to keep things tidy. At is similar to cron in that it runs something at a scheduled time, except at only runs it once. And it's a separate system from cron, although it uses the same daemon. And it has a kind of an interesting format. If I do at --help, what? Okay, I guess I don't have it on this one. I guess, let me close this. Let me go to my CentOS server. Let me undock that. Log in as student. capital P at SSW0RD. All right, so if I do at dash help, it tells me, okay, that's not a valid option. So it tells me my options. And basically, it wants me to give it these options like verbose or queue or a particular file. We're not going to talk about what these are, but you can find them in the man page. And then a time specification, right? So let's see what time it is right now here. So right now it is 13:35, right, in this computer. So if I do at, I think it'll take 13:36. Let's see. Okay. Then I can give it a list of commands that I want it to do. How about echo hi there? And I'm going to redirect that into my home directory, into a dummy file, right? I can keep doing more and more commands here. When I'm done, I press Control D. Control D is an end of file. I can see the scheduled tasks with at Q, right? And it shows, okay, yeah. So Friday, April 22nd at 13:36. So that's tomorrow. It must have already passed. It must have already passed. So that's fine. So let's try this again. Date. Yeah, my fingers weren't fast enough. Let's try 1340. And we'll do echo new test. And again, put that into my home directory dummy. I'll put this dummy.file and Control D to end it. And now if I check my queue again with that queue, it shows both of them. One is today at 1340, and there's nothing in my home directory right now. Oh, it's too far ahead. I gotta wait 3 minutes, but you get the idea. And I can clear. I can remove things from the queue with @rm. Let me do help. So @rm expects a job number. So if I do @q, it tells me, actually, where is the job number? What's that? So is there a number right here that I'm not seeing? Yeah, I think it must be because I'm cut off, but it's kind of strange. But I can't. Oh, well, there we go. That's what I was looking for. But no, see, it does that sometimes. There we go. There we go. All right. So I can do @rm1, and it will remove that job. And if I check the queue, we see that that job has been removed. So again, at a simpler system than cron, but it's only for running jobs once. So, okay, I don't want to do this backup now because people are using stuff. I'm pretty sure people will be off of it later. Let me just schedule it for 10 o'clock tonight, right? Sorry, date. Yeah, we got to wait 40 seconds. But you get the idea. That's pretty straightforward. Okay, who am I? The question, who am I, is not really meant to get an answer. The question, who am I, is meant to dissolve the question. And actually, if you really get into Linux ID and who am I, you will dissolve because it's insanely complicated. We're just kind of scratching the surface of what you need to know. So let's do this. Let's do ls. All right, my dummy file showed up. So it did work. I'm going to go ahead and close this. So I'm going to go back to Ubuntu. Let me go ahead and undock that again. And full screen that again. And let's do who am I? And let's add a user named Jim Bob, and let's become Jim Bob, right? Just to see what that's like. So who am I? I'm student. Sudo user add Jim Bob. My password, and then su Jim Bob. Oh, you know what? This isn't going to work. Sudo su Jim Bob, because Jim Bob has no password. So if I do su Jim Bob, it expects me to put in Jim Bob's password. So I can't do it that way. So I either have to give Jim Bob a password, or I can just do sudo, and then I am acting as root, and root can become whoever they want. So now if I do sudo su Jim Bob, now if I do who am I am Jim Bob, right? The other command to see who you are is ID. ID is a little bit more full featured, and it also shows me the groups that I'm in. So that is, often more useful to you, but who am I is the more traditional way. Let me go exit, go back to being student. So how do I change who I am? Right? There's two ways. There's a set UID executable. And when we talked about permissions, we talked about this. You guys remember that? So one of the special bits that can be set for any permission is the set UID or set group ID. And if it is set, then that program, when you run it, will run as the owner and not the person running it. So the way you can find all those on a system, by the way, is find and then check the permissions /4000. So that is in the special octet at the beginning, it should have a 4. What is this part of the command doing right here? It's dumping the errors to null, right? And then if you do that, you'll find that /bin/ping has a set UID bit set. And we can just kind of look at that just to see what that is. So let's do ls-l/bin/ping. And you can see, oh yeah, look, it has the set UID bit set, right? If you have an S there instead of an X, that means that it's set, and it is owned by root, which means when you run ping, you run it as root. Why? Why do you think that runs as root? No. But why would you need to give ping root level permissions? It's got to talk directly to the network. It's sending ICMP packets. So it has to talk directly to the network card to do that. So it needs elevated privileges. But not every user is going to be allowed to elevate their privileges. But anybody who uses ping has to be able to do that. So that's why many commands need to have that SUID bit set. So when I run ping, so if I do ping 127.0.0. It's not going to find. It's supposed to be 127. Right? This is running as root right now. It has to in order to access the network card. The other way that you can change your user ID is the set UID family of system calls, which is what we do when we use set user SU, right? When we run the command SU to become a different user, we're using that system calls. So what are the rules? A process running as root can set UID to become any other user. That's why we could do sudo su Jim Bob, because running it as root means I can just do it. Root can become anybody. So you have no files that are private from root. You have no access that root can't do. Second rule, a process not running as root has severe restrictions on how it can use SUID. In most situations, it cannot. So it'll only work if I know the password for the user, or like things like sudo, right? Where it'll allow me to run things as root because I'm part of the sudo group. Finally, any process can execute an SUID program as long as it has adequate file permissions. So going back here, we see that everybody has read and execute permissions for ping. So everybody's allowed to execute ping as root. Does that make sense? This is where permissions get really hairy. And this is where a lot of privilege escalation attacks can take place. So you do need to have a firm grasp of this. All right. So what are user IDs? There's two main user IDs that we talk about, the effective user ID and the real user ID. And we can see them if we use euser and ruser. Let's go ahead and run that command there. Clear ps-e. What's -eo going to do? E is for everybody, and O is no. No. Some of you were just doing this lab last week. Specify the output columns, right? So I say I want everybody's information and I want to specify the output columns I'm interested in. So I'm interested in the process ID, the effective user ID, the real user ID, and the com. So I want the process ID, the effective user ID, the real user ID, and the com. And so what's process ID 1? What's that? It's not the kernel. It's not the message log. It's the thing that starts all the other processes. It's the first process. It is it's what we control with system CTL. It's what on the old systems would have been init, right? It is the mother of all other processes. So obviously it was run by root, and its effective user ID and its real user ID are the same. And like 99.99999% of the time, they're going to be the same. I don't know if we even have any examples here of them being different. And I don't even know, because sometimes we're going to do some examples and try to make them different. Sometimes it doesn't work. That is, the way that they have the kernel set up, or the way they have PS set up, it won't actually show you a different effective user ID. So if this doesn't work, consider it explanatory, if not effective. There's also S user and F user. So F user is file user. In almost every case, the file user account is the same as the user account, but not every case. But that's the user ID on the file system. So every file system, you could have a different user ID effectively. S user is your saved user. And this comes down to, like, if I use sudo to do a command, right, or a series of commands, it is unsecure if all of them are always executed with root privileges, right? The thing we're trying to do is use root as little as absolutely possible to still make it work. So we don't want to use root if it's not possible. So what it will do is, when it needs to become root, it will elevate the privileges to root and then go back down to the previous user. While it's elevated as root, it has a saved user, which is the lower level person it'll go back to as soon as it's done doing the elevated thing. Doesn't come up very often, whereas effective and real do come up. So you can, treat this as informational. just know that there are more user IDs than that. There's a lot. All right. So let's try it. Let's see what we can do here. Let's see if we can sudo sleep 60 ampersand. So I started sleep in the background, right? And I started it with sudo. Let me do one without sudo. Sleep 60 ampersand. And now if I run that same command again, yeah. Because of the way that Ubuntu spawns the sleep off of the sudo, in this case, the root, the effective and the real user ID are the same. On some systems, it would show you a different effective user ID. Let's try another one. Let's try ping again, though. What if I do Control R, ping? Okay. What if I try this? And I'm going to put it again in the background. And it's going to keep doing that, which is annoying. Nope. See, it's running as it's running as student. So every time the process actually needs to access a network card, that process is elevating its privileges, but only for that section of it. So I'm going to go ahead and foreground 3 and Control C to kill it. Yeah. So we weren't able to see a difference in the real user ID and effective user ID. You might be able to on the CentOS, and you might be able to on other servers. And it's just that most modern Linux kernels are better at keeping the privileges unelevated unless they absolutely have to be. So you don't see the difference. We can look for files that have that set UID or set group ID set by using this command or this command. Real quick, why? Why is that the way that we find Yeah, that's 4,000 or 2,000. Why? Remember we talked about this when we did permissions. No, that was hardware, major, minor numbers. Remember we talked about changing permissions symbolically or numerically, right? In binary. So let me just show you here. If I let me create a file here. Touch dummy.file. And if I do chmod 4,000 dummy, and if I do ls-l dummy, you can see that it has that sticky bit set, right? If I do a more common one would be like chmod 766. Is that right? No, 755. So that is, this has the set user ID bit set, and then everybody's allowed to read and execute it, right? So we know we've talked about the 3 octets, right? But there's actually that 4th octet there, and the 4-bit sets is set user ID. The 2-bit is the set group ID. If I want them both to be turned on, how would I do that? Good guess, but no. flip both those bits. So 4 plus 2 is 6. Right? So you can numerically set that. And that's why this find command looks the way it does. So that says find, start looking at the root directory, any file that has these permissions. The permission that has a 4, that is the SUID bit set, or a 2, that is the set group by the SGID bit set. And that's, you know, if you're ever doing like root to boot type hacking type stuff, that's one of the first things you do is let me find, are there any files here that get elevated privileges that I can take advantage of? Everybody with me? Okay. All right. A little bit of conceptual information here. AAA, authentication, authorization, and accounting. This is one of the ways that our system has to kind of be secure, right? It enforces AAA, authentication, authorization, and accounting. Authentication, what does that mean? Credentials. Proving you are who you say you are, right? Authorization. Exactly. Once I know who you are you allowed to do this, right? And then accounting. Keeping track. Once you do it, who did it? Who did what? Who altered the file last? Who printed this off, right? Most modern file systems actually don't do that much accounting, because if they had to account for everything that happened to every file, it would just be, there'd be so much information. But there are sensitive, what they call sensitive file systems. That is file systems that will track every action that any user ID takes to it. In fact, that was one of the ways that back, you know, geez, it's been 10 years now, but Private Manning, when she was accessing all of those files, every time they were accessed, that left a trace, right? So a good accounting system does keep track of that. In most modern operating systems, you can't keep track of everything, right? So you would have to have a special secure file system if you want to keep track of any time anybody reads anything. The base system for doing it in Linux is PAM, right? Pluggable Authentication Module. So let's take a look at, and let me zoom in a little bit because it's hard to read this. What happens when I type in who am I, right? When I type that in, that command, who am I, what has to happen? Well, the process that's running, the who am I process, has to ask the kernel, hey, what's my effective user ID, right? So it uses that get user ID system call. It says, hey, what's my user ID? What's my effective user ID? Then it's going to open up the password file. Then it's going to go line by line through the password file. Okay. Let me look at the portion of the password file that has the user ID. Okay. Does this user ID match the one that I got from get user ID? My effective user? Oh, nope. Okay, let me go on to the next line, read that. Right? Boom, bada boom, bada boom. If it gets to the end of the file and it never found my user ID, then it fails. But once it finds the line that has my user ID, it's going to print that out to tell you this is who I am. This is really labor intensive for a system, considering how often you have to authenticate people. So if you think about who am I, me typing that in, I don't type that in constantly. But if you think about every time I touch a file, every time I try to go to a directory, every time I try to save something, it has to figure out if I have permission to do that. If it had to go through this process and read that password file, that would not be the most efficient way of doing it. So that's the traditional way of doing things. And it had these problems. There was no system-wide standard for encryption protocols. That is for things like passwords. You know, there was no way to say everybody has to have their password encrypted up to this level. It assumed that you had access to the encrypted password. So a user would have to give a password. I couldn't have a process do a thing with permissions later on. It had to have a password. it assumed you had to prompt the user for a password every time they wanted to access it, which is annoying. Anybody remember that with Windows Vista when it first came out? How it would prompt you like 8 times every time you wanted to elevate your privilege? Yeah, it's a nightmare to do that. So you don't want to be bugging people all the time. And it assumes that you want to use passwords. So this system only works if you're dealing with the password file and the shadow file, right? But what if I want to use tokens? All right. What if I want to use smart cards, biometrics, use my thumbprint? None of that works in this system. So PAM, the pluggable authentication module, was developed by Sun Microsystems in 1995, and it kind of fills in all those holes. So you have to understand it because every system since 1995 uses, well, actually, that's not true. You could probably find Linux systems pre-2000 that don't use it, right? But everybody for the past 20 years uses it. So you have to have a basic understanding of what it does. It's a system of shared libraries for authentication. So instead of doing it that way we just described, hey, we're going to have this standard way using these standard library modules that everybody will use. So it'll be the same for who am I, or when I open up a file, right? Everything checks who I am and what I'm allowed to do the same way. To authenticate a user, an application hands the user to PAM, and let's PAM handle it. Let's go ahead and take a look at the PAM configuration file kind of briefly. Not a lot in here. PAM is too complicated to have a single configuration file anymore. And it tells you, hey, most programs use a file under etc pam.d. So let's take a look in there. Pam.d. So these are some of the common ones in there. Actually, let's just cd into there. And let's take a look at change password. So I'm just going to cat change password. And this just calls on another file, common password, which is pretty common. So let's just take a look at that one. And this is where it actually gets into what it does. So this gives you the information about the file. This is a description. This file is included from other ones. This explains what options are there. So this says password, which will be success or ignore. And it's going to come from PAM_Unix. PAM_Unix.so is the actual code that somebody wrote. So this is a configuration file which tells you what are the rules for what code we call and how we use it. But the actual code is under PAM Unix. And that will either say he's entered his password in the past 10 minutes, so I know he is who he says he is, or I need him to enter his password, right? Or he has a token in the machine and I don't need him to enter his password as long as he has a smart card in, right? That's going to depend upon how you configured your system. But if it's success, we'll continue on. If it's the default is ignore this. We'll talk about what all these lines mean later on, what PAM requisite means. What do you think PAM_deny is? Deny access. If you get to that line, no. PAM permit, right? So this calls the permission one. Check your permissions. So they're all. It's also got a keyring one down here. Check your genome keyring. I don't know if Windows uses a keyring. I know Macs. Anybody had to update their keyring on their Mac, right? Or sometimes your Mac will ask you to put in your password to access your keyring. So that's a common way to keep a whole bunch of different passwords on one keyring on an operating system. So PAM has the ability to go check that outside of the regular system, which is again why we moved to PAM, because it's pluggable. We can update things. So what are the options? So there's a function type. The function that a user application asks PAM to perform here, right? Am I asking you to authenticate? Am I asking you to check a password? Am I asking you to authorize, right? Then there's a control argument. This is going to change depending upon what you're looking at. And then the module that we're going to run to do it. I'm not going to look at the man page with you right now. You will have to look at it during your lab. Make sure you read it carefully. So what are the function types? What can we ask PAM to do? We can ask it to authenticate a user, right? Prove they are who they say they are. We can check a user account status. Are they authorized to do something? We can do a session function. Perform something only for that user's current session, like displaying a message of the day. Or sometimes you'll have a session, and during that session, you'll be allowed to do something like change a variable. Password, right? Change the user's password, other credentials. So password's kind of a special one. Right? That's not a general purpose one. Let's go ahead and run this command here. Let's actually stop. Let me explain what this command is. grep stands for regular expression search, right? GNU regular expression. So I'm going to say, I'm doing a regular expression search. I'm going to say, hey, with file name. So if you find it, tell me the file you found it in and not just the line. I forget what the dash capital P is. And then I'm looking for authenticate a user, and I'm checking the whole directory. So I'm finding all the files where I have an authenticate user function type. So let's try grep with file name -p th. And I think you have to have the /t here. Is that right? Yeah, because there are some files in there that have AUTH, but it has to be followed by the tab, so we know we're looking in the right spot. And /etc/pam.d/star. So these are all the files I'm searching. So I found it in check function, in check shell, right? Lots of different places. So here we can see checking the authentication. It's sufficient. Anybody know what this is? It's saying your root, you can access it, right? One way or another. So this can also call other things that might have you enter in a password. This can check to see, are you running something with an SUID bit, right? So any way that you can prove that you're root, do any of them come back true? If so, that's sufficient. Well, what does that mean? It's sufficient. I'm glad you asked. Sufficient means if this rule succeeds, the authentication is successful, don't need to check anything else. Good to go, done. If it fails, take a look at the next rule. Requisite says if this rule succeeds, PAM proceeds to additional rules, right? So it says this is required, but just because this is true doesn't mean you're done. You still have to check the rest of it. If it fails, right, then it's unsuccessful. I don't need to look at any more rules. Required is almost the same, except if it fails, it's always going to fail overall, but it's going to keep looking at the other rules. Right? So required is different in that it still goes to the other rules, even though your total authentication has failed. And you may be like, well, why would I do that? Right?
Well, if you pick errors out, will it tell you so you know which one failed?
No, it won't. But this is going to keep going because you can have side effects that you might need. For example, I may need to check how many times you failed logging in so I can lock out that account, right? So by having required there, I can have that come later on in the process. So what does that look like? Let me zoom out a little bit again. So if this is this is a pretty standard, I don't know if this is on our system now or it was, or this is just a standard example. A pretty standard authenticate, right? So we try to authenticate, it's sufficient. Root OK is sufficient. What does sufficient mean? If I'm successful, you're done. I don't need to keep going, which makes sense. If I'm root, yes, you can authenticate as that person, whoever they are, right? If that fails, then I'm going to go to the next line where it's going to check shells for requisite, right? So that's going to check, is your shell in the shells? Requisite means? It means if it fails, we stop. If it succeeds, we keep going to the next roll. Then we'll check PAM Unix. PAM Unix is your default logon or default authentication system. So it's going to check your user ID and see if you need to enter in a new password again, or check if you have a token or whatever. If that succeeds at that point, again, that point is sufficient. So we end there. And then if it fails, we go to the next one, which is just, it says it's required, but it's just pam.deny. That will always deny, right? So if it gets to the end, which is a very common thing, you'll see a lot of them end with pam_deny. And that just means if you've gotten this far and nothing succeeded yet, nope, you're done. Now, you can better kind of understand that system by looking at a flow chart, right? So it starts the request to authenticate. Are you root? Is root trying to authenticate? Yes, done. Root can authenticate. He can get it. Nope, failed. Well, let me check. Is the shell in shells? Because if the shell is not in shells, we can't do anything anyways. We're not going to check anything else. Oh, it is in shells? Okay, let me check with PAM Unix. And that PAM Unix is the point, that's the code that's going to open up a prompt and ask you for a password. And then it's going to return, yes, your password was successful, or no, it wasn't. Is it successful? Okay, then authentication is successful. Isn't? Nope. Then we go to pam.deny. So here we end up to authentication failed because pam.deny always does. Here we got it because this was requisite. And if the shells fails, we're going to end up down here. Does that make sense? That's kind of the process. You will, in some situations, need to manually edit these files. Not commonly, but there are times where you need to go in and change the way that PAM behaves for security reasons. So you need to have an understanding of what the files look like and how they behave. The advanced control syntax inside the square brackets allows you to manually control the reaction based upon a specific return value. So mostly it's been success or failure, right? But if you have, if a PAM module can return different numbers, then you can do different things. And that's where we actually saw that earlier. Yeah, here. So if it was 1, it would be success. If it was, the default was to ignore it, right? What modules do we have? Well, we can check that by checking our manual page. So man-k PAM_. What does a -k do in man? How would I learn what -k does in man? Man. So if I do a search for -k, apropos options, right? So apropos means sounds like, looks like. So when I do this, it's saying, hey, something that has this in it. Okay. So this is everything that starts with PAM. So these are all of the different PAM modules we have installed. Message of the day, it can handle mail, right? Last log, groups, all of these different things to either authenticate, authorize, or account, right? That's what PAM is concerned with. And remember, most systems don't do that much accounting. Everybody with me? Any questions on PAM at this point? All right, that's it. That's all the new topics that we have. I'm going to go ahead and stop recording this.